Okay, we're setting up a shower system, hot water for students here, and we need a heating for the hot water. I'm going to use this beer keg here, to stainless steel beer keg, to use as a fire heating. I'll put a fire in it to heat. So we're in the process of pulling this down, stripping it down, ready to make into a system. I've already started to cut out the top. Remember, something like this is going to have pressure in it because of the pressure, and also that it's empty. As I cut the first cut, it released air. I don't have the mechanism. To make the cuts in this, I was using the 9-inch angle grinder to quickly cut it. Just going to use a screwdriver to break off the last bit so it's right, cut right through. That's the spear for the keg, which removed the booze. Okay, I'm about to cut out this section here, which will be where the fire is lit in here. So it's just going to give us an access. So I'm going to use, I'm not sure if you can see that, I've got it marked out in pencil. I'm going to cut out the piece here, and we'll keep this piece for the door. I've marked here, it's where we're going to put some holes to put the copper pipe in. The holes will have to be big enough to take the 3/4 copper pipe. We'll be drilling through. Stainless steel is very hard to drill. It's a soft metal, but it actually binds up your drill bit, so you need a special paste to go on the drill bit. We're going to see how we go. Okay, so now we have the hole made for putting the fire into, the hole made for the chimney, which will be up on top here, the 2 holes in here that we drilled for the copper pipe. There will be a copper pipe coiled inside. The cold water will come down here into here. Then I'll coil 3 coils of pipe inside. The pipe that will come out here and go up will have the hot water in it as it's heated, as it goes through the keg. This is the 3/4 copper pipe that I'll be using to make the coils with. This is hard drawn. You can get a softer material than this, but it's more expensive. This is a bit of a challenge to get the hard drawn. I've got to bend this without kinking it and get it inside the keg. Okay, we used heat and we've managed to get the pipe wrapped around this other keg, which is smaller as a template. Now I just need to work out how to get this into there. Okay, now we've got our coil pipe ready to go in. First of all, we have to silver solder on the elbows, which will help it to stick out here to attach our pipes to through the holes. So I'm going to silver solder these on. Okay, so now we've got the coil ready, and see how we've evenly spaced it, and it's all uphill. There's a little bit not quite right there, but it'll be fine. We need it. What we need is the thermocycle, so we need the hot to be able to rise. If it has any low spot, the heat won't rise, and then you'll have a problem because it'll just boil in the tube, and that's not good. So this is all evenly spaced so it can go up. Now we have to try and get this into here, through here. Now hopefully we've done it the right way, and it looks like we have. I'm going to put it in that way. So now we're going to try and get it in there without changing the twist. Good so far. We'll get tighter. Nearly. Very close. Things have progressed somewhat from where we were before. We've actually used this already. We've run a course, and it's already heated water for about 10 people having showers, and functioned quite well. Mind you, it was a bit inefficient. We were going through quite a bit of wood. So I did have some bricks around it to try and hold the heat in. We're going to put some more bricks around to make it more insulated, and there's going to take a slight process to do that. At the moment I don't have the protector on the chimney. This is the chimney going up through the ceiling. Here I have a protector around that, and that's so people don't burn themselves. Also it holds the heat in, and there's more that we want to do with that in time. Okay, so we're connected now. We're connected into the system, and it is thermocycling, and I'll show you that. So here we have the cold water coming down and into the bottom, and then the hot coming up. The hot comes up, across and through, up into the tank here. The cold comes out of the tank. This is where the cold comes out of the tank on the thermocycle. This is the cold coming in here, and then this is the hot supply coming from the top of the tank, and this is the cold inlet supply coming in. So now we have put the bricks around for insulation. It's insulating the pole here so it doesn't get, the wooden post doesn't get hot, and we still have access into the firebox. I want to adobe over this in some form to try and seal it some more. But now we're getting somewhere. This system that I've used is actually quite simple. It's something my father showed me when I was a younger child. However, I would much prefer to use the new concept of making a rocket stove. Rocket fire with a combustion chamber. In time maybe I'll make a combustion chamber to adapt into here in the rocket stove concept, which is much more efficient. But with the insulation around here, it is going to be quite more efficient than what it was.